In this video, we're going to go ahead and get our files uploaded to our server. So what we have to do is write some web API code that will allow us to deploy our launcher and our client. So what happens when we deploy a launcher or a client? Well, we're going to get a entity created, either the client entity or the launcher entity. Both of these inherit from the upload entity. And then we're going to get a file added to our file system somewhere on our website. And then when a person requests the latest client or launcher, they're going to be able to do that and also be able to get a link to download the particular objects. So what I want to do in this video is get our upload actions working. Our upload actions, again, will have to accept information about the upload, such as its version, and it'll also have to accept a file that will be uploaded and put into a folder. A couple additional things I want to go ahead and add to my upload class. I want to keep track of the file name that the user uploaded, and I also want to keep track of its size. We're not going to be using that information really, except for the download, of course, because we want to replicate the file name that the file is uploaded as when we download it, but we won't be using the size anymore. I just want to put it in there so that we have that information in case we ever need to use it in the future, maybe for auditing purposes or something. It might be nice to be able to get a report breakdown of how much space our uploads and our clients are, or our launchers and our clients are taking. So to add the fields that I want to, jump into your abstract class upload, and then we're going to add in public long size, or how about file size in bytes. And then we're also going to add a public string original file name. So once we get that up, we're going to have to fix the spelling of original, because for some reason I always like putting a O in there. I don't know why, but it just sounds original, I guess is how I pronounce it. So there's like an O in there. I don't know why I like putting an O in there. But anyway, so now we have our file size in bytes and original file name. We'll be populating these fields on the upload actions. Let's jump into our package manager console. Make sure that we have our default project set as, once it loads, data, and then we're going to add migration, add size and name to upload. Then wait 1.5 years for the migration to be created. And we now have our migration created. So let's go ahead and apply that migration by doing update database, which will of course apply our migration given the connection string that's defined in our startup project. And again, our startup project is marked as buzzmmo.web. Okay, so I don't want to turn this into a video about HTTP, but there are some hurdles. After I go ahead, I'm going to scope to that. But there are some hurdles we're going to have to overcome in order to do the upload properly with ASP.NET Web API. Let's head over to Postman. Now, I don't have the project actually running yet, so it's going to hit, like if I hit send right now, you see it's just going to come back with an error, and that's okay. Because what I want to show you guys isn't the response that we're going to get back. I want to show you guys how the request itself is made. Because in order to understand the code that we're about to write to pick up that data that we need with our files and our additional metadata, we'll have to understand why we have to write that code in the first place. And to understand why we have to write that code, we have to look at what the browsers actually send to the web server in order for these requests to be made. So what I'm going to do is I'm going to go ahead and construct the request as I want it to appear. So I'm basically designing what I want the API to accept. So this is the request format that we're going to have to keep in mind when we write the code that actually performs the uploads. So what I'm going to want to do is I'm going to want to set a timestamp, which is going to be some arbitrary value, a version, which is going to be also some arbitrary value, and then a file. So we're going to call this file upload, and it's not going to be a text field, it's going to be a file field. We're going to choose a file, and let's go ahead and upload littlepip. It's just sitting there on my desktop for some reason, but it's a good event.ini file to test this out with. So we're sending form data, but we're sending data, like timestamp and version, in addition to sending a file. What that's going to do is it's going to send it as what's called a multi-part request. And we can inspect that request by hitting F12 and opening up our Chrome tool. So you can, of course, ignore all these errors because it's telling us that, well, the server's not running, so it's not receiving a response, and that's okay. So what we want to do is we want to hit send and click on this right here in our network tab. So you want to make sure that you have your network tab selected, then click on this upload request. And again, it's not going to return anything important, but what it does show us is a very interesting request payload. So as you may know, an HTTP request is a combination of headers, like what we see up here, and it's also, in addition to the headers, if it's a post request, which we are doing a post request, it's going to send a post body. Now the format of that post body is going to be dependent on the content type of the request headers. Now the only way to send files over HTTP, or well, I shouldn't say the only way, but the way in which you will commonly be sending files in HTTP, for example through a form element or something similar, is going to be with the multi-part form data content type. The multi-part form data content type also has something called a boundary, which is a random string generated by the browser that doesn't exist in our payload, so that it can separate between the different parts of the multi-part request. I mean, multi-part, if the English definition of that word is, well, you take multi and then part, so they're multiple parts. And so what the browser is going to do is it's going to split up the request into multiple sections, and it's going to delineate those sections with a boundary. So as you can see here, every single part of this request is delineated by this WebKit form boundary, which again, there's really no particular reason why it has to say WebKit form boundary. The browser can make up whatever boundary it wants as long as it specifies it in the content type. And also we'll see that our bits also have content dispositions. Now content disposition is a special header that is included for every part of the multi-part request, and it contains metadata about that content. So we see that we have 3 bits. One all 3 of them have a content disposition of form data, but you'll notice that 2 of them simply have a name equals blah in addition to the form data. So we have name equals timestamp, name equals version. Then we also have another one up here, content disposition form data name upload file name equals littlepip.png. So what's cool about that is we'll be able to know which bits of form data are a file and which bits are just arbitrary data that we would also like to include in the particular request. So that way, when we go ahead and write our upload code, or the logic that'll be executed in our build process, we'll be able to construct a corresponding multi-part form request just using the basic built-in HTTP client functionality of .NET, and it'll allow us to include our timestamp, our version, and our file itself. So I wanted to talk about this just so the code that we're going to have to write makes a little bit more sense, because unfortunately ASP.NET Web API doesn't, or it has a couple of built-in methods for dealing with multi-part form data, but I'm not a big fan of any of them. For example, one of them will allow us to handle both arbitrary string form data, but it'll require that we pass in some folder for it to upload our file into, and I don't really like that, because as you'll be seeing, we have a bit of a catch-22. We can't save the file until we know the ID of the client, but I want to load the file, but in order to load the file we have to read our payload to establish our timestamp and our version, And we can't create the client or the launcher entity unless we have our timestamp and version, and we can't have the timestamp or version unless we load the entire form field, which requires us to load our file. We'll solve that by simply writing our file out to a temporary location and then reading it back in once the entire request payload is parsed. Now, fortunately, ASP.NET Web API gives us the ability to hook into its request processing for multi-part data, and we'll take advantage of that to write a class that will read this data for us in a way that's appropriate for us. And it's not a particularly long bit of logic either. So let's go ahead and get started with that. The first thing I'm going to do is uploading our launcher and uploading our client are so similar that I want to make a static method somewhere that will just encapsulate the logic for doing either of those things. So yeah, and then that's going to, what that code's going to do is it's going to instantiate our custom stream provider or multi-part form data stream provider, which we'll implement first. It'll then tell it to parse the request. It'll then establish the timestamp and the version. It'll add the row to the database. Then if that's all successful, it'll copy the temp file, or at least move the temp file to the new location. And the new location is going to be inside of a special uploads folder in our project. And the file name is going to be the ID of the upload that was added to the database. So yeah. Let's go ahead and get started. The first thing I want to do is I want to write the multi-part form data stream provider class. That's the class that's going to be responsible for parsing our request payload in the way that we want it to. So let's fire up our infrastructure folder and let's create a, as far as the name goes, I don't want to conflict with the existing multi-part form data stream provider. So let's do multi-part data provider. I don't know what else to call it. Multi-part data provider. And it's going to inherit from the multi-part stream provider class. Now, multi-part stream provider class comes from systemnet HTTP, and it'll be used, it's used by ASP.NET Web API in order to process our multi-part payloads. However, by inheriting from that class, it necessitates that we overload or override the single abstract member called getStream. Now, the getStream method, what it'll do is for every single one of these content items, these are called HTTP content, is the class that these are going to be encapsulated inside of. Every time the Web API hits one of these, it's going to ask us to provide a stream, a writable stream, where it'll dump the data that it finds in this request. So it's going to say, okay, so we got this HTTP content, but we don't have the data that was in this HTTP content yet. So could you please provide us with a place in memory that we can dump this data into? So for example, we could pass in any kind of stream. We can pass in a custom stream. We can pass in a file stream or a network stream or a memory stream. What we're going to be doing, however, is a little bit more complicated. And the reasoning behind why we're doing this will become a little bit more clear. But I want to go ahead and before we write the getStream method, I want to write the constructor of multi-part data provider as well as his data members, because then hopefully the how we're going to be handling this will become a little bit more clear. So let's go ahead and create a constructor for multi-part data provider. He's going to take in one parameter, and it's going to be of type func, the delegate func, of string and stream, called file stream factory. And this is going to require that we bring in a reference to using system at the top, which will come up there. And then I'm going to have file stream factory be stuffed inside of a private read-only field of the same name and the same type. Now, file stream factory is basically going to allow the person who instantiates the multi-part data provider to give it or return it a stream to stuff a particular file into. So this serves two purposes. First of all, when we instantiate the multi-part data provider and we give it a delegate that satisfies file stream factory, that delegate is responsible for A, determining if it accepts that file to begin with, meaning the string parameter of this delegate is going to be the name of the file, which is found right here in file name. Or sorry, it's name, sorry, not file name. So it's going to be checking the name. So the first responsibility is to say, okay, do we want to accept a file named upload? If we do, return a file stream to somewhere on disk, in this case a temporary file, to stuff that data. If we don't accept that file, return null. And the reason why we return null is so that we can kind of queue up a list of errors, because the way that this provider handles the request payloads has to be made in a very specific way, and because of that we want to queue up errors in case we run into things that we don't know how to handle or can't parse. Okay, so now we have our file stream factory. Next up, we need a place to stuff our so I'm going to bring in dictionary, which will bring in systems collections generic. We need a place to stuff our form data. So for example, where are we going to stuff timestamp and version? So we need a bit of a container to hold that data for us. So we're going to do that in form data. Then we need a list of, well, we don't really need a list of files, but I want to keep track of a list of files anyway. So we're going to have a list of HTTP content files. And then finally, we'll have a list of string called operation errors. Now we're going to go ahead and have to write our properties to access these fields. First of all, we'll have an IEnumerable of HTTP content called files, which will simply return files. We'll have a public IEnumerable of string called operation errors, which will simply return operation errors. And then we'll also have a public bool is valid that'll return true only if operations errors has no items inside of it. So if operation errors.count is 0, then return true, meaning that this is a valid, we're in a valid state. Finally, before we move on to other methods, we will have to go ahead and write our constructor, because we have to instantiate our collections. So we have to instantiate our form data equals new dictionary. We have to instantiate our files equals new list of HTTP content. And we have to instantiate our operation errors equals new list of string. So now that we have all of these collections instantiated and we have our public facing properties written, we can go ahead and start working on our getStream method. But there's one thing I want to do before that. And that is, it isn't immediately obvious with what we see with this request payload, but some browsers are going to quote things. So they're going to quote our names, and I don't really like that. I don't want to deal with that. I want to remove these quotes when it returns the content disposition headers, so that we're not dealing with them, because they would become rather ugly and, yeah, bad. So we want to write code that is able to trim double quotes off a string, and that's fairly straightforward to do. And then we're going to sanitize all of our names with passing it into that method. So the method is going to be pretty straightforward. It's going to be a private static string trim quotes. It's going to take in a string input, and it's simply going to return input.starts with quote and input.ends with quote and input.length is greater than 1. And then the question mark for opening the first case of the ternary. Input substring 1 input length minus 2 colon or minus 2 colon input. So this code will simply check to see if it starts with a double quote and it ends with a double quote and its length is greater than 1. Because if we passed in an input that only had a length of 1 and that only character in that string was a double quote, it would technically start with a double quote and it would end with a double quote, but it isn't something we want to trim because that would actually result in an invalid operation exception on our substring invocation. So not only do we want to make sure that it starts with a double quote and ends with a double quote, but we want to make sure that it has a length greater than 1 as well to prevent a potential exception being thrown. Now, if these conditions are true, then we want to return input.substring1 and input.length -2. That'll chop off the first and the last character of our string. If these conditions are false, we just want to return back input because we don't want to do anything to the string. Okay, so that's just a little helper method that we'll be using here very shortly. So let's write our getStream method. Now our getStream method first needs to do one of two things. Remember, getStream will be invoked on every one of these blocks of content, every one of the parts of a multi-part form data. And it'll give us some information from the headers. So you see that each one of these bits has some headers. So for example, this one, they all have content dispositions, of course, but this one also has a content type, and we can arbitrarily add as many headers as we want to each part of the multi-part request. But fortunately, we only really care about the content disposition, and fortunately for us, ASP.NET Web API makes working with the content disposition very easy. So getStream is going to do one of three things. Either A, we are dealing with a basic form element, such as timestamp or version, in which case we return a memory stream. B, we are working with a file and our file stream factory returned a valid stream, in which case we return that stream. Or C, we are working with a file and file stream factory returned null, which means we're going to log that as an error and return a memory stream. So those are our basic options for dealing with this, dealing with our getStream method. Okay, so let's handle all three of those cases. Stuff and things. So first of all, what we want to do is we want to say if string.is null or empty headers content disposition dot file name, then return new memory stream. Again, the content disposition file name will be null or empty if we're dealing with a normal form field and not a file. And since getStream is responsible for returning a stream that is writable, that ASP.NET Web API can stuff data into, we just want to return a new memory stream so that it'll stuff that form data into a memory stream. Next up, we're going to say var file stream equals file stream factory, and then we're going to invoke it, passing in trim quotes. Okay, come on. What? Visual Studio is just going crazy. Trim quotes, headers, content disposition, name. So remember, the parameter to our delegate is the form name of our file, so that it can decide if it's going to return null or if it's going to return a proper stream. Then we'll check if file stream does not equal null, return file stream. Otherwise, say operation errors dot add. We're going to say file placeholder is not supported. And then I'm going to wrap this in a string format, and I'm going to pass in headers dot content disposition name. Then I'm going to return new memory stream. The reason why I'm doing this and not throwing an exception right here is because if I throw an exception, ASP.NET Web API will wrap that exception, meaning that I won't be able to catch on the particular exception that I want to in order to handle this error case. So that's why we're writing this code so it won't throw any exceptions, but then we're queuing up all of the errors into this operation errors collection so that we can handle those errors in a different way with our client code. Because like I said, otherwise those exceptions will get wrapped, and dealing with wrapped exceptions is kind of a pain, and that'll decrease the ability for our client logic to be able to handle particular errors. So in this case, we can queue up our operation errors, and then at the end of it, we can either log it or send it back to the user, or both log it and send it back to the user, or just ignore it. I mean, whatever we want to do. And of course, we have to return a valid stream anyway, so we're going to return a new memory stream. Okay, so that's our getStream method, but that doesn't actually solve all of our problems. You'll notice that we haven't added anything to our form data or our files collection yet. That's because when getStream is invoked, we don't actually have the data yet. We don't have the data that was passed in, like these numbers or this file. And of course, Chrome isn't going to show us the file here for obvious reasons, because it would take up a lot of text and space. But we haven't yet populated these collections. So how do we do that? The easiest way to do that is to handle the execute post-processing async method. So what I'm going to do is I'm going to say public override async task execute, oh come on, execute post-processing async. This method will be invoked after all of our parts of our multi-part request were populated by ASP.NET Web API into the streams that we passed in to our thing, into the streams that we passed back from our getStream method. So this is the method where we're going to want to loop through all of the parts in our multi-part request and then stuff the appropriate content parts into one of these two collections, either form data or files. So let's do that. I'm going to say for each var content in contents. Now contents is a property on the base type of our stream provider that will be populated by the time we get to the post-processing async method. Then I'm going to say if string is null or empty, content.headers.contentDisposition.filename. So if we're dealing with a normal form data element, I'm going to say var key equals trim quotes content headers content disposition name null coalescing on empty string. So key will either be empty string if name was null, or it'll be the name that was passed in with the part. Now here's where things get a little tricky. I don't want to support the being able to pass in multiple bits of form data with the same name. Meaning if I passed in, up here in Postman, if I passed in two things that were named version or two things that were named timestamp, I don't want to handle that case. That does happen from time to time with certain things, but in this particular example, I think handling that use case would just require us to write a bunch of code that we'll never actually end up using. So what I'm going to do is I'm going to say if form data contains key, then operation errors add, or how about multiple values with the same key of blank are not supported. And then I'm going to pass in key, and then I'm going to type in continue. So if we have a request that has multiple keys or multiple parts that have the same key, then we'll just add to our operation errors. Remember, when we add to our operation errors, our isValid property will return false, indicating to the user of this class that we're not in a valid state. However, if it doesn't contain the key, then we'll simply do formData.add key, and then we're going to do something a little funny looking. We're going to do await on content.readAsString async. So we're going to add to our form data, and then we're going to pull out the string data of this particular part using the await keyword. Of course, the await keyword is supported because we have the async keyword up here on the top. And we are going to be reading the data as a string asynchronously. Okay, so if it has a file name, so else, then we're simply going to do files.add content. All right, so that's our execute post-processing async method. By the time this is done, we will now have our form data and our files collection populated with our contents of our multi-part request. There's one more thing that we have neglected, and that is we haven't written any public accessors for form data yet. So that's what I'm going to go ahead and do. I want to go ahead and write the simplest, most straightforward accessor for form data that will also allow type conversion as well. So what I'm going to do is I'm going to say public bool try get form data of t, string name out t value. Then I'm going to say string value, if not form data try get value name out string value. Then value equals default of t, return false, meaning we weren't able to extract even the string from our dictionary. Otherwise, open up a try. Actually, is there a convert? No, there isn't. So we're going to have to say open up a try. Value equals cast to t, convert dot change type, string value, type of t, return true. And then we'll have a catch that returns false and sets value to default t. Okay, so the try get form data method will attempt to extract the string value. If it can't, it'll return false and set our value to default. Of course, because value is an out parameter, we're going to have to set it to something on every single branch of execution for this method. Then we open up a try block and we try to convert the value, the string value that was extracted from our dictionary into the type that we requested by the caller. If that is possible and it doesn't throw an exception, then return true, indicating that value is now populated with the type converted value of what we wanted. Otherwise, if there was an error, set value to default t and return false. Okay, so we have now written our method that'll handle parsing our multi-part request. So the next thing is I want to write a method that'll be shared by both my client API and my launcher API. So let's go ahead and do that. I'm going to jump into infrastructure and I'm going to create a new class, and it's going to be called upload service. It's going to be static because we're not using IOC in this project. If we do go ahead and refactor this project in a way that I'm more comfortable with, then we definitely will be making this class non-static and inject it into our controller. But in this case, we're going to just have it be a static method. It's going to have a public static async task, which I have to bring in task from system threading, so system threading appeared. HTTP action result, which will bring in system web HTTP. The method will be named upload. Now, the upload method is going to require that we pass in a couple of different parameters. First of all, we need to pass in our database. So I'll say MMO database context database, because we need our database for this method. Next up, I'll pass an HTTP request message request. This is required for us returning our responses from the upload service itself. And then we'll have a func in system of type upload in BuzzMMO data entities called upload factory. Okay, so this method could probably be cleaned up in a couple different ways so that we don't couple ourselves to our database or our HTTP request message, or couple ourselves with our HTTP action result. But again, I want to keep this as simple as possible, and this could very easily become a topic of future expansion if anybody is interested in that. Okay, so now what I'm going to do is I'm going to write our upload method. So our upload method is first going to create a temp file. So we're going to say var temp file name equals path will bring in system.io. Get temp file name. So a temp file is a uniquely named 0-byte temporary file on disk, and then it'll return us the full path to that file. So it's a very convenient way to create a temporary file that will later be cleaned up by the runtime. Now we have to instantiate the provider, because we need to have ASP.NET Web API use our custom multi-part form data provider in order to parse the request. So we need to instantiate that object. So I'm going to say var provider equals new, what did I call that? I can't even remember what I called that. Multi-part data provider. Multi-part data provider. Now our file stream factory is going to be simply name goes into name equals upload, ordinal case ignore, or ordinal ignore case. If name equals upload, then return file.open temp file name with a file mode of open. Otherwise, return null. So again, this delegate we're passing in does indeed satisfy our requirements on our multi-part data provider. It checks to make sure that we are dealing with upload, and if we are, it'll return a file stream to our temporary file. Otherwise, it'll return null, indicating we don't support that particular form field. Now, we can make this logic as complicated as we want if we wanted to support multiple file uploads in the same request. But in this case, we're only accepting one, so we only have to handle the case, two cases. Is this the file we're looking for, or is this not the file we're looking for? So that makes things pretty straightforward. Now we have our provider instantiated, we have to tell ASP.NET to process our multi-part request using the provider we just instantiated. So we're going to type in await request.content.read as multi-part async, and then we're going to pass in our provider. So what that code will do is it'll read the multi-part data, and it'll use our provider to parse the multi-part request. Now that we've done that, our provider is either in a valid state or in an invalid state, and it may or may not have our form data that we want, and it may or may not have our file that we want. So the next few bits of code is going to be me validating that we do have a valid request, at least as far as we can validate. So we're going to say if not provider is valid, then return new bad request result request. Now bad request result will necessitate bringing in system web HTTP results. Then we're going to say int timestamp short version. If not provider try get form data timestamp out timestamp, or not provider try get form data version out version, then return new bad request result request. So this code simply extracts our timestamp and our version from our provider. Next up, I want to say if provider.files.count, which will bring in system.link at the top, does not equal 1, then return new bad request result. Okay, by the time we get to this line of code, we know we have a valid request because we've extracted our timestamp and our version, and we know we have a file. We also know that that file is saved at the temp file name location that was created on the first line of this method. So now what we can do is we can instantiate the upload entity. So I have this upload factory, which is a delegate, and it returns any object of type upload or one of its derivatives. So we'll use the different method invocation or different lambdas for our upload factory argument to determine if we want to instantiate a client or a launcher. So what we're going to do is we're going to say var upload equals upload factory, and then we're just going to invoke it. Then we'll say upload.uploaded@at equals dt.utcnow. Upload.version equals new build number. Now that'll bring in buzzembo.base at the top. Version and timestamp. Then we want upload dot, what else do we want to set? We want to set the original file name, which is going to be our provider files. Well, actually, we're going to be needing the file reference 2 times, one for setting our original file name and one's for setting our file size. So I'm going to change the logic up a little bit. instead of saying if providers.files.count does not equal 1, I'm going to say var file equals providers.files. Actually, I'm just going to say for single. And I'm going to do this after we check to see if our count is not 1. So we ensure that there's only one file in our providers, and then we extract it using the single link extension method. So now that we have our file, I can say original file name equals headers.contentDisposition.filename. Then I can say upload.file size in bytes equals file headers length, I believe, will give us the... a better way to do this maybe would be to just get the file size of the temporary file. Because you can... if for some reason the content length isn't set, which I don't think it was set when we sent that request through Postman. No, it wasn't set. So because the content length wasn't set, we don't know the length of our file. So it'll be easier to instead do something like file dot oh, come on. Is it get attributes that gives us the size? No. Give me a second. I need to remember which one of these methods it is. I guess we can just do new. I always like doing that. New file info temp file name dot length. Yep, length. So file size in bytes equals new file info temp file name dot length. I had a little bit of a forgetful moment there. Anyway, so now we've set our uploaded that, our version, our original file name, and our file size in bytes. We can simply do database uploads add upload database save changes. All right, we have one more thing to do, and that is to move our upload from our temporary file location to our new file location, which is going to be in our uploads folder. So how do we get in ASP.NET Web API, how do we get a reference to one of these folders in an absolute sense? Well, if we were in the context of an IAS request or an ASP.NET request, we can use HTTP context, which is typically what you would use in ASP.NET MVC. But we're not in ASP.NET MVC, and the HTTP context isn't as readily available to us. Now we could cheat and do what we did with the authorized deploy token attribute and extract the HTTP context from our action context. But I kind of don't want to do that. I kind of don't want to cheat, because in this particular instance, the process of getting a folder, an absolute path to one of the folders in our web application, is actually very simple, using what's called the hosting environment static class. So what I'm going to do is I'm going to say var new file name equals path.combine hosting environment. Now hosting environment will bring in system.web.hosting. Then I'm going to say dot map path. Map path is equivalent to the map path method in our HTTP context.server. So what we can do is we can pass in a virtual path using our familiar squiggly, and then passing in uploads. Then on path, the second parameter to path.combine is going to be upload.id.toString. This could possibly return null, but I don't really care. I'm going to actually disable this suppress warning. I always like putting my warning suppression up at near the top of the method that it's used. Yeah, so we're going to just suppress that warning real fast, because I don't even know, is there even a case where this can return null? Because that's kind of silly. Why would it do that to me? Let's see here. Oh yes, it will return null if hosting environment dot the hosting environment is null. And if hosting environment dot the hosting environment is null, there's no way that we can get the uploads anyway, and I really don't care, so let's just let that happen. So yeah, I don't care about that possible null exception. And then, so what this code does is it gives us an absolute path to our uploads folder, which doesn't exist yet. We'll create that here in a second. regardless of where our application is deployed to. Then we combine it with the ID, or the toString result of the upload ID. So it'll be 1, 2, 3, 4, 5, basically just the ID of the upload row, which is fine. It makes it very easy for us to access that piece of data, and it, more importantly, ensures that our file names are going to be unique. After all of that, I'm just going to say file.move temp file name to new file name, and then I'm going to return a new OK result, passing in our request. All right, so that's our upload helper method. All it really does is it's broken up into a couple different parts. It first parses the multi-part request. It then validates the multi-part request. It then creates a new upload object and saves it to the database. Then it moves the temporary file into our new location. So yeah, I think that just about wraps up our upload service. So let's go ahead and put it to use. I'm going to jump into our client API. So I'm going to go to controllers, API v1, client controller. And at the top, because we know we'll be needing a database, I'm going to say private read-only MMO database context database equals new database. And then on upload client, I'm going to do a couple things. I'm first going to say if not request.content.is multi-part content. Now, is my multi-part content is an extension method that comes from the HTTP namespace. So by auto-completing to that, we get system net HTTP, I believe. So if it's not a multi-part content request, then we know there's no file in it, so we can simply return bad request. Otherwise, I'm going to say return await upload service dot upload underscore database request, and then a upload factory that returns a new client. Okay, you'll see that we have two errors, and these two errors are due to the fact that we didn't update our return type of our upload client. So we're going to update our method to be public async task of HTTP action result. And of course, task of anything is going to require that we bring in system threading tasks at the top of the file. But yeah, so this will handle all of our stuff. We ensure that we're doing a multi-part request. And if we are, we return the result of invoking upload, passing in the database, passing in our request object, and passing in a lambda that instantiates a new client, because we're wanting to work with clients and not launchers. So if we go ahead and hit Control F5, we'll see if we got this to work. Of course, we will need to create our uploads folder. So go into your base project, create a new folder, and call it uploads. You'll want to make sure that this uploads folder is added to your CS proj. This can be important later when we talk about deployment. However, you do not want to add any of the files that are uploaded into the uploads folder to your CS proj, nor do you want to commit them to your repository. We'll add an ignore path here in a moment after we test it. But just make sure you have the uploads folder added and it is added to your CS proj. Okay, let's come over here to Postman and let's just hit send and see what happens. We get a bad request. All right, so let's go ahead and debug this. I'm going to go ahead and hit F5. And Visual Studio is going to decide to freeze on me. All right, hit F5, jump into upload. Let's just walk this file down line by line. I'm going to jump over here to Postman and hit send one more time. And let's see what happens. Okay, so we get our temp file name, which is good. We instantiate our provider, that's good. We read as multi-part async, that's good. It is valid, that's good. And then we are unable to acquire our version for some reason, we can't get that data. Okay, let's go ahead and try this again. I'm going to do that. I'm going to hit send. Oh, come on. Let's try that one more time so I don't accidentally skip out. Okay, so this did extract our timestamp. With our version, we get our version out as a string value. Ooh, and then we hit an exception, and yeah. That number that we passed into version was so large that, as you can see right here, this number is so large, it can't fit into an int16, or it can't fit into a short, because a short is just an alias for an int16. That's fine. That error I'm not too concerned about, because we should never have versions that large anyway. If we do have this many versions of our MMO, that probably means that the universe has already ended. So let's make this number a little bit smaller. Let's do 5436 or whatever we want to type in. Then let's hit send, and we get a 200 OK. So now let's see what happened. Let's jump into our uploads folder. I'm going to right click and say open file and explore, and we get a 16. Let's open up MySQL Workbench and see if we get that row added. Let's see here. Tables, uploads, select, and let's see here. We indeed have a 16. We have a timestamp, which is our timestamp, our version, type of 1, which is 1 is our client, uploaded at, file size in bytes, which that is correct, original file name, littlepip.png. I do want to get rid of those stupid quotes, though. Let's jump back into our upload service. Our original file name equals files, headers, content, disposition, file name. What I want to do is I want to jump into my infrastructure multi-part data provider class, and I want to make my trim quotes method public. Now, you know what I want to do? I want to take this trim quotes method and I want to turn it into a extension method on the string class itself so that we can reuse it anywhere in our project. So what I'm going to do is I'm actually going to unscope out of buzzmmo.web, go into buzzmmo.base, and I'm going to add a new namespace called extensions. Then I'm going to add a new class called string extensions. Then I'm going to make it static, because extension methods have to be in a static class. And then I'm just going to take this trim quotes method, and I'm going to cut it out of our multi-part data provider, and I'm going to paste it into our string extensions CS file, again, which is under our extensions namespace under our buzzmmo.base project. And then I'm going to make it public instead of private. And then I'm going to add the this qualifier to its initial parameter, meaning that that is now an extension method. Now we can invoke trim quotes on any string in our entire project. Seems like a fairly useful thing to do. Let's also rename this to trim double quotes, because it only handles double quotes, it doesn't handle single quotes. So to avoid confusion, because we've now promoted this method to be solution-wide, just to make our code a little bit clearer, we'll want to qualify that we are trimming double quotes and not single quotes. Maybe in the future we'll also write a method that handles single quotes as well. Now that we've done that, we'll have a couple of errors in our multi-part data provider class because our trim quotes method is now an extension method and not a method of this class. So we basically have to invert it because this is now an extension method and not a static method or a normal method. I'm going to simply remove it and then dot at the end of name and say trim double quotes. Now doing name.trim double quotes is going to necessitate that we bring in buzzmmo.base.extensions at the top of our file, because extension methods require that we include the namespace that they are in order to use them. Then this method, instead of doing trim quotes, I'm going to remove that. I'm going to leave the parentheses, and then I'm going to do .trim double quotes at the end of it. to give us the exact same behavior that we had before. Okay, so now we have trimmed double quotes as an extension method. We can come into our client or our upload service, and instead of doing original file name equals file headers content disposition file name, we can now add dot trim double quotes. And of course, by doing that, ReSharper has added a using buzzmmo.base.extensions at the top of our file. Okay, let's go ahead and hit F6 to recompile. Let's come back to Postman, and let's make the same request again. We got a 200 OK back, and if we refresh our query, we now have original file name being set properly. Let's make sure that the file came back without any corruption. I'm just going to double click on one of these files and open it in Windows Photo Viewer. And hey, look! We indeed were able to get this file without any corruption at all. Just making sure in case there was an extra line feed or something that would have destroyed our binary file. It looks like everything is indeed preserved correctly. Okay, so let's go ahead and test our error conditions really fast. Let's remove timestamp. By adding that, we get a bad request. That's good. Let's change the name of our upload. We get a bad request. That's good. Let's add a duplicate key. We get a bad request. That's good. And let's go ahead and just remove everything and send an empty request. And we get a bad request. That's good. So we are validating against all the conditions appropriately. All right, the last thing I want to go ahead and do is hook up our upload launcher method. So let's go ahead and do that. Let's jump into our controllers API v1 launcher controller and find our upload launcher method. Now, fortunately, this method is going to be pretty identical to our upload client method. So I'm just going to put them up side by side here. Of course, I will need to come up here to the top and say private read-only MMO database context database equals new database. Then I'm going to have to change the signature of our upload launcher method to be public async task of HTTP action result, which will necessitate we bring in system web HTTP as well as system threading tasks. Then I'm saying if not request content dot is my multi-part contents, which will bring in system net HTTP. Return bad request. Otherwise, return await upload service dot upload, passing in our database, passing in our request, and then passing in a lambda that instantiates a new launcher as our factory. Hit F6, and let's see if that works. So coming back into Postman, let's change the URL. Instead of hitting API v1 clients upload, let's hit API v1 launchers upload and hit send. Oh, we didn't. We get a bad request. Actually, that's good because we didn't fill in anything. Let's set timestamp to some arbitrary value. Let's set version to some arbitrary value. And then let's make a file upload called upload. And let's go ahead and upload that, I guess. Hit send. We get a status 200 OK. We do indeed have that file uploaded. And if we look in our database, we will see that glyph icons halflings has been uploaded to our database. So we now have that little indication right there. And we'll also notice the type is 0. That means that when we query for this particular row, we'll get back a launcher, not a client, as per TPH. Okay, I think that just about wraps up everything I wanted to do in this video. So, yeah, we'll see you guys in the next one.